Alright, picking up where we left off, we had just found the maximum and minimum there in red at x equals pi fourths and at x equals 5 pi fourths. And if we evaluate those into our function f of x, which is sine x plus cosine x that we originally given, we find that the corresponding output f of x value for pi fourth is square root of 2, and then the value at 5 pi over 4 is actually negative square root of 2 over 2. I'm sorry, negative square root of 2. And so we can use those pieces as we're creating our graph to actually take a look at plotting some points. So let's actually get started on the graph since we have some details that we can put into it now. So just like we mentioned in class, we're only going to go out to 2 pi because the graph will repeat the same picture before then, or after then, as it will keep repeating that picture. So we'll have values at square root of 2 over 2, which is a little bit bigger than, well, it's about 1.4. So let's mark in here. I'm going to mark my pi over 4 values here in red, since those are the ones I was getting. So we've got, at pi over 4, we've got about 1.4 here. And at 5 pi over 4, we've got about negative 1.4. All right, as mentioned in class, another thing we could find is to find the x and y intercepts and then the inflection point. So let's do the inflection point next. So the inflection point is found by taking the second derivative and setting it equal to 0. We already found the second derivative there, boxed in green. It's negative sine x minus cosine x. So the second derivative set equal to 0 means that we have negative sine of x equal to cosine of x. So what we find out is we want to find the x values where sine and cosine are the same value but opposite signs. And that's actually the other two pi over 4 values that I didn't get from the last equation. So that's at 3 pi over 4 in quadrant 2 and at 7 pi over 4 in quadrant 4. So down here on the graph, if you're taking a look at 3 pi over 4 and at 7 pi over 4, we have these inflection points. So those are my two red values here and here that I didn't have values at before. So we can plot those points by actually evaluating our function, the original function, at 3 pi fourths and at 5 pi fourths. And if we do that, we actually find out that we get an x value of 0 plugging those in. So not only was that a helpful thing to find, that was actually our x and y intercepts that I mentioned finding as well. So there's that max. Put them in. And then we have the x-intercept here and the x-intercept here. The only last thing that we haven't done is to find the endpoints, and I think that would be a good idea sort of to finish out the graph. So we can find f of 0 and f of 2 pi, and if we evaluate those into the function, we actually find out that each of them are equal to 1. And so we have points here at 1 and over here at 1. And if we connect all of our points, we can actually talk about how that inflection point plays out, and you can see that at this spot and at this spot the concavity changes from concave down to concave up and then back to concave down again. So this is our sketch of our graph that we've been working with, and actually I didn't quite finish that out right. Let me do that again. The graph keeps going up because it's going to go up for a little bit further before it hits that peak again. All right, we have one more example. This is the example that's going to look a little bit different depending on when you printed out your version of this. This is one of those sketch of the graphs ones. And in order to do this one, we start with the first pieces where we actually are given some points. So we're actually given some values here of f of 0, f of negative 1, and f of positive 1. So using those values, we found a value of x intercept at 0, 0. At negative 1, we're at positive 1, and at x equals positive 1, we're also at positive 1. So those are the first 3 points that they're giving us right here. All right, for the next pieces of information, we're told stuff about the derivative. So the derivative, again, tells us where it's increasing and decreasing. The first one tells us that the derivative is positive, meaning that it's increasing. So our graph is increasing before negative 1, so that's over here. And it's increasing between 0 and 1, which is over here. So we have something that looks like this going on the graph on those pieces. Now we may have to fix them in a minute. In fact, I know that we will, but that's the more or less the picture that we have going on. The other piece of information about the first derivative is right here, and that tells us that it is decreasing. So the graph is supposed to be decreasing between -1 and 0, so something like this, and decreasing after the x value of 1 greater than 1 over here like this. So this looks kind of like an M or something like that. We're going to have to change a little bit of it because then the next thing that they tell us is actually some information about the derivative, which is the second derivative that's about this section. So this is the concavity issue. This actually tells us that it's concave up because it's positive. So concave up means it opens upward. It looks like our traditional parabola, potentially, that we've seen before. And this actually happens before -1, between -1 and 1, and after 1, which means that the graph actually at those values of -1 and 1, we don't have a concavity to talk about at those particular places. So this was our original graph that we were looking at, and let's actually take a look at what we would have instead now that we know that information about the concavity. Now it's still going to have to do that increasing and decreasing business, but just not in quite that sharp of a way. So if the graph is supposed to be increasing and concave up, it would have to look something like this. And then between -1 and 1, it would have to connect and look like this, and then maybe after this, it would have to look like this. And it may level off somewhere, and it may not. It could still be decreasing much more quickly than this, but still it has to be concave up. So this would be a sketch of this particular graph.